pleasant evening and a warm welcome to all who are present here. The foregoing generations beheld God and nature face to face, we through their eyes. Why should not we also enjoy an original relation to the universe? These are the lines from Ralph Waldo Emerson's book, Nature. We take all that has been bestowed on us for granted. We have been exploiting energy sources, potentially leaving centuries to come in darkness. A belief that the first step in establishing an original relation to the nature is to protect and conserve resources so that future generations can enjoy what we enjoy today. IEEE Student Branch Chapter of NSS College of Engineering Palakkad presents before you UNPLUG, a national level energy conservation, efficiency and management contest that aims to reduce power usage by inculcating awareness in young minds. As part of the session, we are here to attend the awareness session where you will learn different ways to reduce power usage, small things to take care of, which will heavily impact the domestic usage of electricity and thereby bring your bills down. So without further ado, let me welcome Abhinav R, our dearest senior, a valued alumnus of NSSE, Associate Software Professional Engineer at DXC Technologies, and most importantly, our mentor and the former chairman of IEEE SBNSSE, who will be in charge of the session. He has always been there to guide us. He will enlighten you on the topics. So let me hand over the session to Abhinav Rajiv. So please take over.
Yeah, thanks a lot, Sneha, for that wonderful words, Mole. Yeah, sure. Okay, we'll start, right? So before that, do we have to take a photo in the beginning or in the after the session? Coordinators, could you just confirm on that? Okay, great. Yeah, so I'll just share my screen. Okay. Yeah, before that, let me make you see me for just for a moment. Okay. So this is me. Most of the people here would have known me. So yeah, that's it. Just a peek to whom I am. Yeah. So coming to the today's session. So there are different people from different category, like different states, right? So we'll continue mostly in English, right? We have to have this session in a more interactive manner. So I just believe that everyone could respond in the chat, or you can unmute yourself, respond to whatever thing I ask, and anything and everything that I ask for you. So I think we can go as a interactive session, right? No response for that. The chats. Utilize your chat boxes. Yes. Yeah, sure. Okay, great. Perhaps I saw the attendees list and I was surprised that around 30 to 31 colleges have been registered for this event, varying from the different colleges in Kerala, and outside Kerala also the many colleges have been registered. So great to see that. So great to see this much of a count and colleges. So I think we can impact more severe community out there, right? So I'll just share my screen. Okay, just tell me if it's visible. I prepared some basic slides. So one good thing about the slides, I don't think I'm boasting. The thing is that the background images were taken by me. Okay. So when the coordinators, Nihala and his team, consisting Alina and all those students, so when I got their attention to make a presentation on the energy segment, so I was considered like she put forward the idea of conserving the nature and environment. It should have been related to the environment in somehow. So I thought, why couldn't I just take some of the pictures on my own and then I incorporating it with some of the slides. So I think the slides are visible, right? Uh, yeah. Okay. Great. Thank you. Yeah. Sure. So Venkatesh, good evening for you and your team. Yeah. Good evening. Yeah. Great. We are here, Unplug. So what is Unplug? It's a 2-day session. Okay, it would be a 2-day session. The first day would be covering all those preliminary things on the basic knowledge, enhancing your basic knowledge on power and energy. And the second day we'll be going into what is an energy auditing. Okay, what is an energy auditing and how you can do it in your house to conserve more energy, to make your more things efficient, and we'll learn some of the management, energy management things. So what is unplug? In the session, today's session will be covering difference between the conservation, efficiencies, and management. So in between, I'll be using a bit of Malayalam. The thing is that to entertain my Malayalam audience, so everything will be clarified to you in English, and the same thing will be conveyed at around some points in the session through Malayalam also. So the main difference between conservation, efficiency, and management will be discussed in this session. Okay. And the appliances at your home. So most of the students, most of the students will be having their doubts on how things work in their house, etc. For your tube, the fluorescent tube, the all tube, how it works, your phone charger, how it works. നിങ്ങൾക്ക് പല സംശയങ്ങളുണ്ട്. മിക്സി ഓൺ ആക്കുമ്പോൾ എങ്ങനെ കറങ്ങുന്നു, നമ്മുടെ ഏതാണ് കരിക്കിന്റെ അകത്ത് കാണിക്കുന്ന പോലെ ഫാൻ്റെ റെഗുലേറ്റർ കൂട്ടുമ്പോൾ സാധനം കറങ്ങാൻ പറ്റുമോ? All those things like a very basic phone charger to the iron machine or the washing machine, everything, you'll be having doubts how things work. So we'll be comparing all those appliances working, and we'll find some solutions for that. Okay. And in the last, we'll be covering the home energy auditing. So the session will last around 1.5 hours. So I'll try to make it as brief as possible. So the first thing, the foremost thing, I need it to be more on interactive side. Okay. So let's begin. So just define. So I just need some volunteers. Okay, from two teams. Okay, here 2 minutes are there, running in parallel. So we'll, yeah. Can anyone be my volunteers from this team? Anyone? Voluntarily? Anyone? Just need 2 volunteers. Anyone? Anyone? Just for some 2 calculations only. Just be the volunteers. Okay. Kuldeep, can you be my volunteer? Are you here? Madhav, are you here?
Yes.
Yeah, sure. Great. So Madhav, can you just define power in your language? Just tell me what you know when it comes to your mind.
Capacity to do work.
Capacity to do work. Yeah, great. Anything else? Other equations and all those things. You have learned all those things in your bachelor's degree or anything like that. Any simple equations, you know?
V equal to VI.
VI. Yeah, great. Yeah, thanks. Thanks, Madhav. Yeah, so as I said, power is the amount of energy transferred or converted per unit time. And we know different equations. Equations we know. We know those very familiar equations, which are some of them P is equal to VI, P equal to watts, or like energy divided by time, and I square R, and also it's a V square by R. It all comes to the single equation P equal to VA, right? Yeah, so this is power, right? Yeah, great. So what is energy? Anyone from this thing? Anyone? Anyone? Alina, are you here? Alina, Katie? Yeah, okay. Capacity to do work. Yeah, great. Thanks, Venkatesh. Actually, do you know any equations on that for the energy? Yeah. Which one? Just tell me. I think your voice is breaking in between. Okay. Anyway, if okay, energy equal to power into time, right? Okay, we got a session like the equations also. So if you say that we got the equation E equal to PT also. So apart from that equations, how you can redefine things? You'll be able to redefine power as this equivalent. You can see here. For an incandescent bulb, it would be 100 watts. അല്ലെ, ഒരു മഞ്ഞ ബൾബ് വീട്ടിൽ കിടക്കുന്ന ഒരു 40 വാട്ടിന്റെയോ 50 വാട്ടിന്റെയോ yellow light incandescent bulb will be having a 40, 60 or 100 watts. And coming to an LED bulb or a CFL bulb will be having around 14 to 15 watts, right? So that's how you should conceptualize the terminologies: watts, power, energy, etc. And the basic equations and the basic definition of power and energy should be redefined as far as we are considering the home energy audit. Okay, you can see that simple power can be defined as a 100 watt LED. 100 watt bulb. What does that mean? What does that mean? So for a simple 100 watt bulb, if the power equal to 100 watts, you know the equation, right? P equal to VI, and we know the standard voltage is 230 and 100 watts into I. So what is I? It's 100 by 230, right? So if you do the basic calculation, we get around what 100 by 230, right? This bulb consumes around 0.5 ampere of current, right? So this is how you should be now. From now onwards, you should conceptualize power as a thing that is capable of handling current or can deliver heat or power. Okay, so just a basic introduction to what is power, right? Yeah, when it comes to energy, we have to redefine it like this. So if you are running your 10 watts LED bulb, okay, if you're running your 10 watts LED bulb for 100 hours, it's just a unit. Okay, what is a unit then? 10 watts into 100 hours, right? Which means it's 1000 watts and hours are there. What is watt hour? It's energy. See, so it's 1 kilowatt hour, which is equal to 1 unit. നമ്മുടെ വീട്ടിൽ ഒരു യൂണിറ്റ് കറണ്ട് ആയി, 2 യൂണിറ്റ് കറണ്ട് ആയി എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ കറണ്ട് അല്ല, ഇറ്റ്സ് എനർജി. It's not energy. It's energy. It's not the current unit. It's the energy unit. In Kerala, we usually say that we are incurred 3 units of current. It's a wrong saying. Okay, 3 units of energy, and 1 kilowatt hour is equal to 1 unit. Just ഇതൊക്കെ ഒരു ബേസിക് ആണ്, ജസ്റ്റ് പറഞ്ഞു വിടുന്നതെന്നേ ഉള്ളൂ കേട്ടോ. Okay, yeah. So can someone define? So which is your favorite appliances in your home? Can anyone? Kirtana, are you here?
Yes, ചേട്ടാവുന്നുണ്ട്.
മോളെ ഒന്ന് പറയാമോ, എങ്ങനെയാണ് മോളുടെ വീട്ടിൽ ഒരു ഇഷ്ടമുള്ള ഒരു അപ്ലയൻസ് പറയാമോ? Can you just tell me one of your liked appliances in your house?
എന്തെങ്കിലും പറയാ?
എന്തായാലും any electrical appliances.
Induction cooker.
Induction cooker, great. Okay, so induction cooker, do you know how much it consumes? What is the power rating? അറിയില്ലെങ്കിൽ ഇല്ല എന്ന് പറഞ്ഞു, ഒരു പ്രശ്നമില്ല.
ഇല്ല, കറക്റ്റ് അറിയില്ല.
Okay, so for a normal induction cooker, it would consume around 1500 watts to around 1800 watts. Okay, so let's assume it to be 1500 watts. Then if it is turned on for 1 hour, how many units you will be incurred? എത്ര യൂണിറ്റ് മോക്ക് ആവും, എത്ര രൂപ ചെലവാകും, അല്ലെങ്കിൽ എത്ര യൂണിറ്റ് ആവും? 1.5 കിലോവാട്ട് വലിക്കുന്ന ഒരു കുക്കർ മോൾ 1 മണിക്കൂർ ഓൺ ആക്കി കഴിഞ്ഞാൽ വാട്ട് വുഡ് ബി ദ ടോട്ടൽ എനർജി യു വിൽ കൺസ്യൂം? What is energy equation there? പറഞ്ഞോ മോളെ, കുഴപ്പമില്ല. കീർത്തന, ഹലോ. Okay, anyway, yeah, the thing is energy equal to power into time, right? So 1500 watts into 1 hour, right, which is equal to 1.5 units, right? For a basic KSEB, the Kerala State Electricity Board, which provides electricity for most of the consumers residing in Kerala, we are having around 4.5 to 5 rupees per unit. Okay, so if you are running a induction cooker for 1 hour or 1 hour, it will consume around 1.5 units, which means the maximum amount that will be incurred by me, the user, is equal to 1.5 units times 5 rupees. Okay, so 7.5 rupees, right? This is the simple energy calculations. Okay, you have to familiarize these things. Either if you're for doing the home energy audit, this would be a better way to understand the energy and power concepts. Okay, so any volunteer from the team? Anyone? Anyone? ആരെങ്കിലും? Someone just voluntarily come out. That would be so far better. Yes, Sanjana, tell me. Yeah, great. Can you unmute? Yeah. കേൾക്കാം. മോളുടെ ഏറ്റവും ഇഷ്ടപ്പെട്ട ഒരു അപ്ലയൻസ് എന്താണ് വീട്ടിലെ? The most favorite electrical appliance in your house? ഹലോ, പറഞ്ഞോ. ഓഡിയോ ബ്രേക്ക് ഉണ്ട് മോളെ. You can put in the chat. Yeah. I think the other one, AC. Okay, you're more on the cool side, right? The one was in the induction cooker, so I think she was more into the cooking and eating things, and you are more on the AC side. Great. Anyway, that's kidding. Okay. So you are considering an AC for your appliance. So do you know how many watts it will consume for a normal AC? Yes or no? That would be okay. Okay, great. So for a normal 3-star or okay 5-star AC, okay, 5-star AC of 1 ton refrigerant capacity, it will consume around 1200 watts. Okay. Then what will be the total units incurred by this AC if you run it for 1 hour? 1.2 units, right? So from now onwards, this should be the primary thing that you should have in your mind. When you're considering the power, the energy, you should know that the units does matter, and we have to be out from these equations. Okay, all those equations where energy, all those equations, we have to change this. We should redefine them to the more appropriate or the practical examples, and also the real life scenarios for the home energy auditing purposes. Okay, now let's see some statistics. Okay, I just built this graph. Yeah, so it's on the guys, I must say, though the values were taken from Wikipedia only. Okay, yeah, coming to the energy sources share in India, the statistics as of 2019, we have the coal as a major production for around 55%, more than the half is produced by coal only in India. And see, for the larger extent, the second place goes for the renewable energy, which includes the biomass, the waste to power thing, the solar thing, the wind power, all those things. And the nuclear contributes only for the 2%, the diesel 0.2%, and the gas 7%, and large hydros, which are the other main sources for energy in India. So large hydros are becoming a threat to the mankind, right? Storing a large amount of potential energy in the form of water in a dam is very dangerous. So as far as Idiki is concerned, in the last flood time also we faced some issues, the leakage and all those things with the dams. Still, this is things are working, as the total overall working cost for the hydro power plants are very less compared with other things. Okay. So this is a very dramatic or drastic change in the energy sources by India. So as you can see, the coal contributes to the maximum or the major part of the contribution, energy contribution. So still in 2017, India has already attained 63% of the self-sufficiency, okay, in part of energy. Still, there are movements and also developments going on in the field of renewable energy to constitute the more in the form of renewable energy in India. So for that, statistics says like this one. The Sustainable Energy Development Goal for 2040, it says that by 2040 in India, the solar power will contribute around 19%. The wind power will contribute around 21%, and other renewables will contribute around 18%. Let's see what it adds up to. Like I think it's 1, 2, 3, 20. Okay, 60% something. Anyway, it's above 50%, right? So the overall goal for 2040 is to reduce the overall consumption of coal and the production from coal to around to around or above 50% by only renewable energy. So that is a Sustainable Energy Development Goal for 2040. I think that's clear, right? And also, if you see, renewable energy in India is distributed as this way. So in 2019, you can see the solar energy is contributing the second position, and the wind has been contributing to the major concerns, and biomass, waste, and small hydros are there, which contributes to the other portion of the pie chart. So it's said to attain a larger amount of solar in 2022. For around 60% of the total renewable energy in India would be contributed by solar itself, and around 40% will be contributed by wind, and the rest by biogas, waste, and small hydro. So these are sublime context in which the renewable energy in India is developing. Yeah, that's some of the statistics. Okay. So what are the concerns? Concerns. I mean, what are the typical energy resources that we use in India? Typical energy resources, as already told. We told that fossil fuels are there, nuclear power, renewable energy, and fossil fuel. Oops, sorry, this one is not there. Okay, editing mistakes. Sorry. Okay, coming to the fossil fuel, what is a major concern? It's limited, right? This thing is limited. We are not known, or we don't know when it will extinguish. According to the statistics and all those things, it says that by around 2050 or 2030, sorry, 2030 something, the fossil fuels will be nearing to its extinction. So after that, there won't be any sources from a fossil fuel to extract. So a concern like that exists, the limitation of fossil fuels. And when it comes to nuclear power, it's a very good ambient amount of power from a small thing, right? The fusion and fission, all those things. Still, the safety concerns are very large. Of course, most of you have already saw the series, like series in the pair there. Anyone knows?
Chernobyl.
Chernobyl. Thank you. The Chernobyl incident and all those things you guys know, right? The nuclear energy, how that can be affect the even the reproduction of the mankind and the upcoming future generations. So it's still a concern for the safety out there in nuclear. And so overcoming these, we can include, or we can introduce renewable energy. So what are the good thing about renewable energy? As far as fossil fuels are considered, this renewable energy is not limited. We got immense amount of wind, we got immense amount of solar sunlight, as long as the sun is there. Okay. So link in the solar plant okay. So energy. Okay. When it comes to renewable energy, it overcomes the problem of limitations as far as the fossil fuels are considered, and also the safety issues. There are no or less safety concerns with the renewable energy. And do you know one thing? Like, it's a fact. The number of birds killed by the windmills in India is around 1 million. 10 ലക്ഷം പക്ഷികൾ ഒരു വർഷം ഇന്ത്യയിൽ വിൻമില്ലിന്റെ ഇടയ്ക്ക് വിട്ട് മരിച്ചു എന്നാണ് ചത്തു. Okay, anything. So around 10 lakhs of birds are being killed by the windmills, the blades of the windmills in India. It arises to a concern how the flying creatures are sustained. So studies are going on, and bladeless wind turbines are coming, and all those things are developments are going on. Yeah, still I just said that's a fact. Okay. So renewable energy, what is the limitation for that? Initial cost, the power production per unit area. If you, for a given volume of area or the place, renewable energy can only develop 1/3 or 1/5 of the total production for the nuclear power plant or the fossil fuels. So that's also another limitation for the renewable energy. So there is always a trade-off. You have to sacrifice one or two things for the betterment or the beneficial of the other one. So that's a real question to which energy to use. Okay. Yeah. Now let's differentiate. So till now, any doubts? Any doubts from any people? Anyone? എന്തെങ്കിലും doubt ഉണ്ടോ? No. Okay. Great. Okay. Great. Thank you. Okay. Yeah, okay, we'll go with the differentiation. So I told that energy efficiency, conservation, and management, the three things are different. Okay, let's before that, let's discuss something. Okay. Another volunteer? Anyone? Mohammed Shaheen, are you here?
Yes.
Yeah, sure. You're from Kerala or?
Yes, from Kerala.
Okay. So the question is simple. Energy conservation. According to you, what is energy conservation?
Wastage ഇല്ലാണ്ട് വെക്കുക.
Oh, yeah, great. That is very appropriate answer. Thank you, Mohammed. Thank you. So that's a very appropriate answer for what is energy conservation. Energy conservation is defined as not the reduction of consumption. It is the reduction of wastage. നമ്മൾ ഒരു എനർജി യൂസ് ചെയ്യുകയാണ്, അതിന്റെ കൺസംഷൻ കുറയ്ക്കുന്നതല്ല കൺസർവേഷൻ, വേസ്റ്റേജ് കുറയ്ക്കുന്നതാണ് കൺസർവേഷൻ. I think you got the point. The main thing is that energy conservation is not dependent on how much energy you consume or how much energy you preserved. It is not about that. It is about how much energy you no, how much less energy you wasted. It is a count or a parameter to define the wastage of energy. So that's a very good answer. Thanks, Mohammed. Yeah, great. Now, so we got a definition, very good definition for energy conservation. Okay, let's go for the other one. Anyone from here? Yes, yeah, Kuldeep. Tell me, can you just explain what according to you is energy efficiency?
Sir, use the energy properly, like
Yeah.
For our purpose we use the full energy without any wasting.
Without a wasting. So well, can you just think a bit more? What is efficiency? Simply, what is efficiency? Simple terms.
Efficiency means the how the input output divided by input.
Yeah, correct. So how we can improve the efficiency? How we can improve the efficiency? From that equation, what all can be adjusted?
The losses can be reduced so that the efficiency can be increased.
Correct. So according to Kuldeep, he also given a very wonderful explanation to that. The basic equation for efficiency is output by input is equal to eta. We all study that, right? So to increase the efficiency, either we have to decrease the input or increase the output, right? So that's the thing. We have to, for the efficiency increase, we have to either increase the output for the same input, or we have to decrease the input for the same output. That is energy efficiency. Thanks, Kuldeep. Yeah, great. Yeah, one more, energy management. So anyone from this team? Anyone? Aditya, are you here? Yeah, just tell me what according to you is energy management. Okay, can you just give me an example? Off ചെയ്യുന്നത്. Yeah, turning off your devices when not needed, right? Okay, that's a good example. Yeah, enough. That's enough. So we can define the energy management as നിങ്ങൾ പണ്ട് മോഹൻലാലിന്റെ ഒക്കെ ഒരു പരസ്യമുണ്ട് KSEB-യുടെ 6 മണിക്കും 10 മണിക്കും ഇടയ്ക്ക് ഇലക്ട്രിസിറ്റി ഓൺ ആക്കരുത്, ഫ്രിഡ്ജ് ഓൺ ആക്കരുത്, ഫ്രിഡ്ജ് ഓഫ് ആക്കിയിട്, all those things, right? So back here in Kerala, we do have the advertisements from our favorite the film stars, Mohanlal, Mammootty, and all those people. They came into the channel and they says that from 6 to 10 p.m. you are not supposed to turn on your fridge, your AC, and other heavy load appliances, right? Why is that? Energy management means managing our loads according to the time period. Okay, for a given amount of time, or sorry, for a given period of time, if you are overloading the supply lines, then the whole system gets disturbed. So conserving that, or keeping a balance in between the supply and your load is energy management. So it's more or less like a conservation, as Aditya told that turning off your things, right? It's right. So turning off your things according to a time period or a given time period, it's the energy management. So let's differentiate that. Let's firstly see that. Okay, what is the time now? It's 39. Okay, great. Yeah. See, energy conservation. A careful preservation and protection of energy can be termed as energy conservation, and it can be simply done by turning off your light to an IoT device to automate your appliances, right? There are people, enthusiasts who build automation systems, right? when you enter into your room, the bulbs get turned on, and when you exit from the room, the bulbs get turned off, right? So that's energy conservation. Okay. Lazy enthusiasts. Yeah. Okay. It's not about limiting the consumption, but it's about limiting the wastage of energy. Mohammed, as you said, that's a great point, and that's a real definition of energy conservation. I hope you got with that point, right? Now coming to the efficiency. For the same output, reducing the input increases the efficiency of a system, right? So I can simply show you an example. Okay. So what is the output lumens of a bulb? Let's see. Let's see a 40-watt incandescent bulb output lumens. Lumen output. Okay. 460 lumens. Okay. Let's see that. 40 watts incandescent, right? Incandescent. Let it be like a incandescent bulb. 460 lumen. Right. 460 lumens. Okay. Lumen output of 10-watt LED. Let's see that. 1000 lumens. See, it overrated. Okay, let's go for some 9 or 7 watts. 7 watts around 460. Yeah, you got it. For a 7-watt LED bulb, you get the same output, right? See how the efficiency increased. What is efficiency? Is equal to output by input, right? So output being same, being the 460 lumens. What is input? We have to decrease the input to increase efficiency. From around 40 watts, we decreased it to around say what 1/4, right? 1/4 of the incandescent, and we got a same output value. So what? The efficiency increase. This is why we move from incandescence and CFL to LED technology. So that's the thing. That's a proper thing of how energy efficiency is managed. Yeah, I think you got the point. Yeah, that's it. And this includes moving from the CFLs to LED conversions, the normal AC to inverter ACs, the normal fridge to the inverter fridges, the CRT monitors to the what's called LED TVs and all those things. So one big question arises was that the initial cost to facilitate the newer technology is a bit higher. It's a bit higher on the side. Okay. So for the same 40-watt LED, 40-watt incandescent bulb, we are getting around 460 lumens. And for that bulb, we are getting around 20 rupees. You are getting that bulb for 20 rupees only, right? For the same equivalent power output and a lower input consumption, we are going to an LED. So what would be the cost for an LED? It would be around 110 to 120 rupees. Around 6 times more initial investment is required for a change in energy efficiency, right? So that's another thing we have to be taken into the considerations. Session കണ്ടിട്ട് നാളെ തൊട്ട് വീട്ടിലാരും പോയി LED മേടിച്ചുകൊണ്ട് വരണം എന്ന് പറയരുത്. So I can give you some tips for like making your own LED bulbs. Okay, yeah, we'll see that. Now, what is energy management? M for Mohala. Okay, so where energy management is when you manage your loads in accordance with the supply. We see that in peak hours, we say that terms as peak hours, say between 6 to 10 p.m. We are having every loads connected, every individual loads connected, and from around morning 8 to 11 a.m. where the companies, the factories, all those things work, we are having a peak hours, right, where the maximum load is demanded. And at that time, if you are having your load also connected to the total system, this can add to the total disturbance of the system. So at that time, if you are if we are educated enough, we can conserve that energy, or we can manage that energy. That is turning your heavy appliances between 6 to 10 p.m. all those things. Categorizing your home appliances. I can say you a simple example. Okay, in most of the front loaded washing machines, there is an option called eco mode, right? Environmental friendly or eco mode is there. So if you are going for a normal wash, it would take around 2 hours to complete. But if you're going for a eco wash, you will take around 3 to 4 hours to complete, but with much lesser power consumption. And what is the thing that we have to do? Apart from turning on the washing machine in between 6 to 10 p.m., we have to turn that at 12 o'clock, night 12 o'clock. Okay, so in the off-peak hours from around 12 to 4 a.m., we will be having the washing machine running at a lower power and also a longer duration, which doesn't add to the total load of your grid and also reduces the heavy load on your from your house side. So those are simple things you can do as part of energy management. Yeah, that's it. So every companies, see, from a big billionaires companies like Apple to the simple Ather scooters, it's not simple. Okay, they were one of the most powerful and what energetic bikes, electric bikes available in India. It's not a bike, it's a scooter. It's having a great platform within the scene, and the Tesla, the Solar City, everything is concerning to this thing, this motive to make their products eco-friendly. So how Apple has planned that? What Apple does is they are planting, or they're planting proper solar panels, and also they're implementing, or sorry, they're planting trees and also solar plants to compensate their CO2 production. They cannot simply give every product a solar panel. So what they do, for every product they manufacture, they either bring out a new solar or renewable energy sector, or they plant a tree. That's their aim and their plan. So every company is investing time in this thing to a better world. It seems, yeah. Yeah. Now let's say some appliances. Okay. Again, I need 2 volunteers. Till now, it's clear, right? When we're speaking about energy efficiency, are we confining the study only to electrical energy, or should we evaluate other forms of energy conservation? Of course, yes. Of course, yes, Heidi. The thing is, we are only considering the electrical aspect. So if you're considering the real energy aspects, then you have to consider even the single uh, the motor vehicle or the car you're using in your house. Even that thing consumes energy, right? In the form of only a petrol or a petroleum product, right? So it comes to the thermal energy and all those things. So moving from a car, IC engine with a 31% overall efficiency to an electric car with almost around or above the 85% efficiency is a typical or a great example for a energy efficient application. But as of now, we are only limiting our studies to the home only, or home energy only. Very good question. Thank you, Harry, for that. Yeah. So I just need 2 more volunteers. Anyone else? Like Suraj, Mona, are you here? Suraj, are you here? Okay. So anyone else in that team? I just need one or two volunteers. Anugraha, Ashwin, anyone? Hello. I'm audible, right?
Yes.
Okay. Yeah. Okay. Khadija, could you be my volunteer? Okay. Thank you. More. Let's go for some appliances. Okay. So for lamps, what all type of lamp you know in your house? What all type of lamp are there? Yeah, incandescent. Yeah, great. Incandescent. CFLs. Yeah, great. Then LED. Of course, yes. So do you know the power consumption of this? Anything? Anyone? Any guesses? Yeah. Okay. 15 for CFL. It would be fine. Yeah. And around 9 watts for LED bulb, or a 10 watts. We can round it to 10. And for same output, incandescent would be around 40 watts. Okay. So how many hours you use your bulb in your house? 6 hours. Great. Okay. So what would be the total energy? What is the equation for energy? Okay. Great. Yeah. So what is the equation for energy? Power into time. Yeah. So here it comes around 240 watts hour. Yeah. Here 15 into 6. Let's see. 15 into 6. 90 watt hour. and here 10 into 6, 60. Okay. See? Yeah, thank you, Khadija. Okay. So 240 watt hours. See, in comparison, we are having around 4 times here and around 1.5 times here, right? We are consuming around more 1.5 times energy, and here what about 4 times? So one more thing, one more aspect, if you consider, which we consider as a cost comparison. This thing is only taking 20 rupees, and this thing is only having 80 rupees, and this thing will be having around 120 rupees. See, what is the cost difference? Around 6 times and around 4 times, right? So we have to justify all these things, right? So I just did a table on that, just a very brief table on that. So let me show you that. See the power. For incandescent, we are considering, okay, 60 watt hour. 60 watts is the equivalent, okay. So that's why you're taken here. And coming to the CFL, it's 15 watts and LED 9 watts. So what is the consumption for an year? As Khadija already told, we are having around 6 to 7 hours. So I just put that as 7 hours, 365 days, and the total power. So around 131 units of energy is consumed in a year with the 7 hours of usage. For the CFL, it's 32 units, and for the LED, it's 20 units only. Okay. Now coming to the lifetime, as an incandescent is a simple piece of wire, it's melting all day, right? Actually, the working principle of incandescent is not the light. See, we are having a light as this. We are sorry for the overrating. Right. This is the filament, right? And this filament is heating up. Okay, heating up. That heat is the primary output. Heat is the primary output for an incandescent bulb, and the light is the secondary output only. That's why these things heat up a lot. Okay, it's for your information. Now coming to the lifetime, incandescent is taking around 1,200 hours only. After that, it might blow. And 8,000 hours for a CFL and 25,000 hours for an LED. So what is the initial cost? One time buy cost. 20 rupees only. It's coming around 55 rupees only. And the nowadays the LED bulbs of 9 watts is available for around 80 to 90 rupees. We can avail them. And sometimes much lower than that. So let's assume a maintenance cost in 4 years. Okay, let's assume the cost in 4 years. So how many hours? So if this is converted to its equivalent days and simultaneously into its years, then we can say that in 4 years we have to invest around 240 rupees for the incandescent bulb to replace the bulb. And for the CFL, we have to invest 220 rupees for replacing in 4 years at a cost of 55 rupees. For the LED, 145 rupees with its huge life cycles with a one-time cost of 90 rupees. And what is operating cost? The consumption is this much units, right? This much units into 4 years. 4 years into 5 rupees per unit. I just assume that. And you see this 2,628 rupees is the operating cost for incandescent bulb. 657 is only for the CFL bulbs, and for the LED only 394 rupees. So what is the life cost for a proper life cycle? If the light is running for around 4 years with all those replacing maintenance costs and all those things, the incandescent bulb is taking around 2,888 rupees, and CFL is only 932 rupees, and the LED is being the lowest at 628.2 rupees. See the difference. So why people at that time in the past people go for the incandescent bulb? The lifetime cost or the initial cost was only 20 rupees. People were more into giving a reduced initial cost for things. People were okay with that. And if I am just investing 20 rupees in every 6 months, it was okay for me. And also the electricity bill, they doesn't matter, as they never knew that this contributes to the major part of the energy consumption. If you say for a 4-year cost, you can see that 2,888 rupees was for the incandescent. We are indirectly paying this much amount for a 4 years for an incandescent bulb. See, that's the thing. So let's go for the fans. Okay, I think this is understood, right? You understand all those things, right? Yeah. Okay, great. Thank you. Okay, now let's go for a fan. Anyone? Just anyone? Another volunteer? Voluntarily come up. That would be great. Yeah, Akshay, one evident. Wow. Okay. What all types of fans are available? Okay, BLDC. So what is the primitive technology? അല്ലെങ്കിൽ ഇപ്പോൾ ഉപയോഗിച്ചുകൊണ്ടിരിക്കുന്നത് ഇൻഡക്ഷൻ മോട്ടർ അല്ലേ? Okay, induction motor. Okay, we are having two types of fans, induction motor and BLDC class. Okay, what is the power for an induction motor? അറിയില്ലെങ്കിൽ അറിയില്ല എന്നാണ് പറഞ്ഞത്, ഒരു പ്രശ്നമില്ല കേട്ടോ. 70 watts. We are having it around 70 to 75 watts. For BLDC? Okay, 35 watts. It's only the half, 35 or 32 watts only. Okay, how many hours? എത്ര മണിക്കൂർ ഉപയോഗിക്കാറുണ്ട്? 8 hours. Great. Here also 8 hours. So if you are having the energy, this would be much greater than this one. Okay. So this will be on the higher side and this will be on the lower side. So what about the cost? സാധാ ഒരു ഫാൻ എത്ര രൂപയാണെന്ന് അറിയോ?
BLDC 2 something.
Yeah, great. It's around 2,600 and varies up to 4,800. Okay. And the base model can be brought for around 2,600 rupees. And coming to an induction motor or the normal fan, it would cost around 1,300 and 1,100, 1,500 range. It is available. Yeah. Thanks a lot, Mona. Yeah, great. So we'll come to that one. See this one? You can see the induction motor and BLDC motor comparison. The same comparison is going on. And one thing that amazed me is that the lifetime of a BLDC motor is 1 lakh hours. 1 lakh hours for a BLDC motor. See, the initial cost 1,300 to 2,600, around 2 times the initial cost of a normal induction motor. Still, for a 4-year operating cost, we are only incurring around 600 rupees. It's more advantage on the BLDC side. See, but it's much more efficient. It's much more 5-star compatible and all those things. Yeah, that's it with fans. I think this is also clear. So move to BLDC fans and move to LEDs. That's a great thing to conserve energy. Coming to the air conditioners. So I'm not going to call anyone. So I'll give out that. For a normal AC, it would consume around 1,300 watts if it's a 3-star normal AC. Even if it is a 3-star inverter AC, it would consume around 840 watts. So one bad thing about induction motors is that it has a inrush current. അല്ലെ, നമ്മൾ ഓൺ ആക്കുമ്പോഴത്തേക്ക് നിങ്ങളുടെ വീട്ടിലൊക്കെ മോട്ടർ ഓൺ ആക്കുന്ന സമയത്ത് ലൈറ്റുകളെല്ലാം മങ്ങാറുണ്ട് അല്ലെ. So that thing it consumes a lot of energy for a small amount of time, but that disturbs all the systems. ആ ഒരു പ്രശ്നമുണ്ട്. Even in the normal AC, for the compressor to start, it consumes a lot of energy. For an inverter AC, it is not having that problem, so it's much more safer to use that one. Okay, things about consumption around 2,800 units, 1,839 units. Lifetime 6 years, and inverter ACs are rated for around 14 years. Initial cost, see, it's comparable around 3,000 to 4,000 or 5,000 rupees. The difference is very limited. And maintenance cost 4 years. It's not much of a maintenance cost. The cleaning and all those purposes, the periodic maintenance services and all those things. Operating cost in 4 years per unit cost per as 5 rupees. Then you can see the life cost of a normal AC would round up to 1 lakh rupees in 4 years. For an inverter AC, it's only the 3/4 of that, 75,000 rupees. That's also a great addition to the total energy conservation. So if you're going for air conditioners, tell your parents that these things are better in what all forms, in the overall life cost, in overall consumption, in overall lifetime, and also what sorry, no inrushes and no other things are there. So air conditioners, great. Okay, televisions, any volunteers, anyone? LED, great. Another one. സാധാ നമ്മൾ ഉപയോഗിച്ചുകൊണ്ടിരുന്നത്
വാക്യൂം ട്യൂബ്,
CRT, cathode ray tube. Okay, great. Yeah, thank you for that. So we do have 2 types of LED. ഇപ്പൊ കുറെ വരുന്നുണ്ട്, QLED എന്നൊക്കെ പറഞ്ഞ് വരുന്നുണ്ട്. There are variations called QLED and AMOLED displays and all those things. So if you're coming for CRT monitors, the power is around 120 watts. See, 120 watts, and for a QLED, it would be, or a LED, it would be a 70 to 80 watts. We watch it for around 4 to 5 hours, right? 4 to 5, 4 to 5. Again, you can see this one is more energy, this one is less. And coming to the technologies, MOLED. MOLED is a type of organic LEDs, and what they do is, in your CRT monitor you are having a cathode ray, right, and the electrons are emitting, and it just something called a phosphorus screen is there. Things like that work on. So a lot of energy is required for this electron emission. When it comes to an MOLED, the individual cell is a LED. Individual. So if you say 1024 by what 980 pixels, or the 1080 pixels, this if you multiply this much, what would be that? Let me see. 124 into 1980. See, these many LEDs are there in the TV, which is distributed as in a horizontal and vertical manner. And these LEDs are able to address individually. You can individually turn on this LED, turn off this LED. So MOLEDs are a kind of display where the blacks. So in an image, if you see a portion as black, if it is a normal TV, it would be a small amount of light would be still appearing there. But in an MOLED, these black portions will be pitch black, which means the processor of the TV just says that that portion of the TV where it has to be black needs not to be turned on. This will be turned off, consuming our energy in that. So every scene we see in our films or any serials or series, we are having dead blacks in some of the areas. So that is how MOLEDs work, just for your information. Okay. So for the same, I prepared again a chart. Yeah. See this one. Around 120 watts, and here 70 watts is there. Total consumption you can see. Lifetime it's 6 to 9 years. It's a maximum. Okay. Initial cost, you can get a normal TV for 6,000 rupees for a 21-inch, and for 8,000 rupees you can get a 24-inch LED TV. And replacement in 4 years, this many rupees will be cost having for the maintenance cost. Sorry, once again. The total cost will be around 1,000 rupees difference for a lifetime. So that's it with the television. I hope that's clear. Okay, now what's up with cooking? So lady minds, what is DLED? Okay, Stephen, I'm not aware of DLEDs. So let me go through there. I'll inform you. Okay, sure. Okay, any lady volunteers or any men volunteers who are interested in cooking? What are the different sources we are available for cooking in our house? Different sources.
Induction cooker.
Great. Okay, any other one? Any others? Indulega, modulando. Okay, Venkatesh, where were you? Any of your friends are here? Hello? Okay.
Sir, I think.
Yeah. Tell me.
I think so. Tarun, sir. Tarun
is there. Yeah. Tarun, where are you? I think he's not in the meet. Okay. Okay, let's go with that. Okay. Okay, Venkatesh, do you know any other sources of cooking methodologies that is used in your house? The primitive ones?
Sir, electric cooker, sir.
Yeah, electric cookers are there. Great. That's a great option. Though I haven't considered that. Okay, electric cookers are there. Induction cookers are there. And also we use LPG, right? LPG, great, Harry. Thank you for that. LPG, we do have that, right? So for electric cookers and electric induction cookers, we'll consider them as the same, as they almost consumes around same energy, 1,500 watts of energy. Oh, sorry, power. Okay. What according to this one, we can't define, right? So for defining terms, we can say that for what that company, Indian company LPG gas, the weight of the gas indulged in that cylinder is around 14.2 kilogram of gas, and per kilogram it is consisting around 12.8 kilowatt hour or 12.8 unit per kilograms. Okay, and if you multiply this, we'll get around 180 something, with around 2 hours of cooking time. Okay, I'll show you that in the slide. I already prepared that. See this one. See, LPG. You are having 14.2 of kilograms of the weight and 12.78 per kilogram. We are having the units equivalent. 60 days, 2 months. We have to change the cylinder, right? And at approximately 2 hours, it will be cooking full time loaded. Total consumption is 12.78 into 14.2. It's around 181.48 kilowatt hours total energy consumed. For the same thing, if an induction cooker is assumed for the 60 days into 2 hours into 1,500 watts, we get around 180 units. These things are similar, right? But the one thing is that the cost we are giving for the both differs. For a cylinder, you are giving around 760 rupees. And you are getting around 180 units, right? And for the 180 units of energy as electricity, you should pay around 5 rupees for 180 units, 900 rupees for this one. But which is better? According to cost, this would be better, right? Still, it's a petroleum product, right? The LPG gas is a product. It's a petroleum product only, not coming from any energy sources, from the hydro or anything like in Kerala. So there is a trade-off dealing with the money or the total profit that we can make and the source from which the both are made. So these analysis or these trade-offs are mostly done by our mothers, right? They know which unit to increase and decrease accordingly, and they find the sweet spot between that. Like for a MPPT in a solar cell or a solar panel, they find out the maximum power point fuel for the LPG and electricity, and they will consume around 40 days for the LPG gas and another 20 days for the induction cooker, or similarly. Yeah. Okay. So that's another thing that I had to say. Okay, that's about the cooking. Okay. Now let's see some practices. Okay, what is the time? 7:07. Okay, we'll finish it in some more time. Let's see some practices. Okay. So practice of cooling. So if you're planning for cooling methodologies in your houses, start from the beginning. Okay. Start from the root. Don't go for these bricks. These bricks are very concrete or a concentrated one. They don't have any holes or other things for the air circulation. These things, these bricks are known as the perforated bricks. They adds up to the total cooling of your house. And as all the film stars and others in the paint shop says, use light colors so that the maximum light or the heat is bounced back from your house. And use of passive cooling. It's cooling is also a kind of heating, right? So if you are in some places where there's extreme cold or something like that, you can use passive radiators. Like you can have a black tinted window so that all the energy from the sun is trapped inside your house and gives you a warmth. So that's a practice for having cooling. Okay, that's also a practice for starting from the root when you're building your house. And coming to the washing machines, go for usage of hot waters. You can use hot water instead of cold water, for which allows for better cleaning of the grease elements in your dresses. Okay, and always start in full load. Go for the full loads. Don't go for a half of the cloths in one go, another half in another go. So it will consume more energy. So educate your parents and other people to start your washing machines in full load, and also use light colors so that it can dry off very quickly. Yeah, and also go for a. I think I just didn't change the writing here, so it's not for light colors. It go for natural cooling, apart from a washing machine. So in this itself, you are having a cooling option also for the thing. So go for a natural cooling of clothes. That's with the washing machine. And coming to the fridge practices, close your door. Close your fridge door. Actually, I'm not supposed to say this as last day also. I just opened the fridge accidentally and I forgot to close. I closed the door, but actually what happened is that one of the apple or watermelon was stucking a bit to the outside, and when I closed the door, they didn't allow the door to be closed. So it was open for I think around 20 minutes. Yeah, for the 20 minutes I got around 1.5 hours of thing from my mother. Okay. Yeah, close your doors, close your fridge doors, and invest in 5-star fridges. Only around 3,000 to 6,000 rupees difference is only there between 3-star and a 5-star. But the 5-star equipments are the king. So always go for that. And give the space. See, this fridges, it's better to see in advertisements and English movies. It's always good to see. But for cooling equipments like the fridge, the ACs, all those requires a minimum space to be maintained in all directions. The top direction, left, right, and the back direction. We have to maintain a specific distance. So the in my house, I'm having a 390 liters of fridge, and that in the manual it says 12.5 centimeter per side. For the 12.5 centimeter, it should be shallow. It should be hollow, like it should be kept free, not like this, for the proper circulation of air and all. So if the proper circulation of air and all is not given properly, then what? The fridge will consume more energy rather than the used one. So give the space. Yeah. Coming to the fan, choose appropriate speed. Yeah, one of my juniors had called me yesterday and told that she just put the fan in boost mode. Okay, she just put the fan in boost mode, and she says like she was flying around. Okay, choose appropriate speed for your operation of your fans. Don't just go for a boost mode or the 5th speed. If it is only necessary, then you can go for it. Else, go for a 3rd speed or something like that. So the one good thing about BLDC fans is that when you're going for the 5th speed, you're consuming around 30 watts. But if you're going for the 3rd speed, you're only consuming 22 watts. And in the 2nd speed, you're consuming only 19 watts or 17 watts. So choose appropriate speeds and use a timer. So it's always better to use a timer. If you're having a BLDC fan, you can set it for 2 or 4 hours. So that even if you forget to turn off your fan, it will automatically turn off after some hours. And clean it. Yeah, of course, if you're having a daughter or a son, take him in your arms and just clean the fan. The backside of your fan, okay. The dust accumulation in there adds up to the total weight. Not considerably, still it's added to the weight and also the input power consumption. So that's the practices with fan you can have. Yeah. Now coming to the cooking, make it blue. So today morning I had my mother in the kitchen saying that its yellow flame is coming. So being an electrical engineer, I was very thorough that I can repair it. So I just opened it, I burned my fingers and I just opened it, put it in the water. And when I opened that thing, I just didn't got any information. So all the holes were clear and all those things. So what I did was I just blow a wind to all the holes again. Once again, simply for the sake, anyway, I opened this thing, right? So I just gave a blow of wind, and after I put everything back, and that magic spell was happened like you kicking off your TV remote. This thing made into the blue flames. So it's not the proper method. So anyway, you can try that. So make it blue and turn off standbys. For an induction cooker, if you are not even using the cooker and the LEDs are turning on, right? There is a condition, right? Simply turning your induction without any plate or പാത്രങ്ങളൊന്നും ഇല്ലാണ്ട് ഇൻഡക്ഷൻ കുക്കർ മാത്രം ഓൺ ആക്കി വെക്കുന്ന സ്റ്റേറ്റ് വന്നു കഴിഞ്ഞാൽ this thing will consume a constant losses of 10 watts. I measured it through with my measurement devices, and I found that simply putting your induction motor in standby will consume around 10 watts. Okay. So the next time when your mother is turning on your induction cooker freely, tell her that I told you to turn off. Okay, now the next thing is flush up with the tops. So it doesn't always don't go for higher flames. Okay, in some areas I saw that when pressure cookers and all those other things are kept, they don't always go for higher flame. And when I ask my mom, she says that the other flame just goes or flows outside. The total energy is not transmitted to the plate. That's a great thing. They know much energy auditing than us. And she just put the flame a bit slower so that the flame is inside the top only. So that's a great thing to have. Just notice that. Okay. Well, from the next time you can go with that. Yeah. I think that's it with today. Now we'll go for auditing, and that's for tomorrow. Yeah. Thank you. You can contact me at any time. I'm not in WhatsApp. You can contact me on Telegram, or you can call me, or you can mail me. Uh, yeah, I think that's it for today. Any doubts? Any doubts? Use dark colors so you can wear it many times. Great. I do prefer black over other colors, and my mother is fed up with my black and blue shirts. Most of the boys will be having a similar situation, right? LPG മിക്സിനെ കുറിച്ചും ഒന്നും പറഞ്ഞില്ല. മിക്സിനെ കുറിച്ചൊന്നും പറയാനില്ലടാ മോനെ. ഇപ്പൊ as of now only induction motor mixes are available as of my knowledge. Let me see. Grinders, right? Grinders, DC, so VLDC grinders, not that much available. Okay, not that much available. So if it is available, it would be a far better. But in a fan and all those things, the BLDC is very much appropriate. Why? Because it is starting in no load, or it has a fixed load, right? Like when it comes to mixie and grinders and all those things, it has a varying load according to what grains you are putting in. The load varies, so that overall energy consumption varies. So that is not a good thing for BLDC motors, I think. Yeah. Can you please share this PPT in WhatsApp group? Of course, yes, I can share that. But make sure whenever you share these slides to anyone, just say these photographs were taken by me. Okay, thank you for that. See all were plain backgrounds. Oops. Yeah, and if you notice, this is in Malayalam we call it as a karvepila. Thanks for my mother. Okay. Solar cookers, of course, it's a great method coming in the colder regions, like in Jammu and Kashmir and all those where solar heaters are taking place. But the one major fault for the solar cookers is the massive size. You can see that solar cookers are having a massive size according to their operation. And the time is okay, but see, for a single 5 kg or a 4 kg cooker, 4-liter cooker, you should have a bigger construction. And there are massive constructions where see. Hello, am I audible?
Yes, sir.
Okay, actually I just lost my internet connection. I don't know what happened. Yeah, I think that's it with today's presentation. So I'm not in the other meet. That's the thing. 1 second, let me reload my meet. No, it's not working. So for the time being, I think that's for today's session. Actually, tomorrow we'll be considering what all factors are affecting the home energy auditing, and how you can conduct an energy auditing on your own in your house, and the report thing, the template thing, all those things will be discussed tomorrow. So that's it with the session. I think that's time for the wind up. Yeah, thank you. Okay, great. So let me be the next call.
I hope there are no doubts. So that's the end of today's session. I hope that all of you have understood how much of a great event you are part of. I thank Abhinav Raji for the great session, and thank you all for joining. I hope you will have the same energy tomorrow as well. So please join on time. Once again, thank you all.